This is going to be a quick demonstration of something really cool. Using EMC ScaleIO as a software-defined storage, transactional store, we're going to move a Percona MySQL database while it's running from cloud provider A into the VMware Hybrid Cloud Service, or vCHS. Now again, we're going to do this while the workload is running. To do it, we're going to need to link together the two clouds, and for that we're going to need some network function virtualization. We're going to use a Brocade Viata Open Networking VPN to create a connection between the two sites. Now here what you can see is the ScaleIO dashboard. Currently we're not doing very much. What we're going to do is we've got 3 SDS instances running inside cloud provider A, and what we're doing here is we're kicking off a database workload, which you can start to see is generating some traffic going to the software-defined storage in cloud provider A. Now if we go and we take a look inside the individual configuration of ScaleIO here, you can see that we currently have got a given number of nodes. These are in fact all of the individual nodes that are providing and serving up storage, and they're providing storage up to the database, which is now generating around 700 megabytes per second worth of traffic. Now to make this demonstration kind of come to life, what we've done is we've created in Cloud Foundry a pretty cool little app which brings together all of the data in one view. What you can see is you can see the database queries currently hovering at around 10,000. They go up and they go down. You can see how much rebalance activity is going on, and you can see how many SDS nodes are running in cloud provider A or in the VMware Hybrid Cloud Service. Now again, this app is going to be querying all the sites in real time, so the data isn't necessarily perfect, but it does show you an idea of what's going on with lots and lots of moving parts inside this demonstration. So you can see we're now generating around 72,000 queries per second, or transactions per second, peaking up and down. So there's a fair amount of load, and it's generating 2,000 IOPS in its peak as the workload goes up and down and up and down and up and down. So you'll also notice that we've got about 32 gigs used of space. And by the way, the read latencies are so low that they're just showing as 0. Because they're below 1 millisecond. Now, what we're going to need to do next is we're going to need to add some ScaleIO SDS nodes to the VMware Hybrid Cloud Service side. It's worth quickly explaining what the EMC ScaleIO software does. It takes any storage that is accessible and it turns it into a pool that can be presented to any host. So what we've done here is we've now said, hey, let's go and create some additional nodes over on the VMware Hybrid Cloud Service. And you can see that the node count is now jumped up to 4. You'll see it go up and down and up and down. Also what starts to occur is immediately we start to see a certain amount of VPN throughput increase between the two sites. What the EMC software-defined storage and ScaleIO is now doing is it's basically rebalancing and redistributing the data between the two sites. So now there's a total of 6 nodes inside all of the sites, and you can see that the amount of rebalancing that's going on is changing to, there's now 6% rebalance, so we've got a lot of rebalance ahead of us, and the amount of rebalancing traffic is now 18 megabytes per second. But relatively quickly, the amount of rebalanced traffic, again, you'll see it go up and down as the data is being completely redistributed. The other thing that's worth noting is that the used space in gigabytes has now also increased, because now we've got 2 sites that are actually part of this common pool of storage. Again, what's fascinating is through the power of a software-defined storage approach, where the transactional storage is being done in software, consuming the storage from these 2 different cloud providers. It's pretty cool that it exists potentially in fact in 2 very different data centers. So you'll notice that during the rebalance, the write latency is going to increase because there's going to be periods where the database, which is running in one cloud provider, is actually writing to the storage inside the other cloud provider. The other thing is that the write latency peaks in those periods will coincide with some rebalancing traffic. Now, ScaleIO actually has very comprehensive controls where you can specify how much quality of service you want to assign for rebalance tasks, for rebuilds, for any individual host quality of service. So very comprehensive capabilities around that. Now, the write latency again is peaking up. You can see that what's starting to occur now is we're now starting to remove the SDS nodes on the cloud provider A side. So notice the database queries are still hovering around 72,000 transactions per second, while all of this underlying stuff is going on underneath the covers, moving all of the data from cloud provider A over to the vCloud hybrid service. Now, after a certain amount of time, after the rebalancing tasks are complete, you'll see that the use space in gigabytes is starting to decline, going from a peak of around 47, and now it's starting to decrease. The VPN throughput is starting to slow down a little bit, and eventually you'll see the node count in cloud provider A go to 0. Again, this is a really useful example, a little bit off certainly the beaten track, but it highlights the power and flexibility that you get with these software-defined storage models, whether they be for transactional block storage, like we've shown here, or whether it's for NAS storage, using the Isilon stack as an example, or using object and HDFS storage, using the EMC Viper object and HDFS stacks. They can not only run on commodity hardware models, but they also enable certain use cases and functions that would be very, very difficult, and frankly, like this one, impossible to do with physical hardware. So you can see that the rebalance bandwidth continues to increase. It's now doing almost 200 megabytes per second. And as the amount of the cluster that is balanced approaches the full-blown, all the data is fully on the vCloud hybrid service. And by the way, just for fun, we added an additional 7 SDS nodes on that side, so we've gone from 3 to 10. You can see that now we've removed all of the storage on cloud provider A as the web app slowly is polling that and gets to the correct value. And you can see that we've now got all of the storage on one side. We've got more nodes, so we're driving more IOPS. The database queries continue to run, and we've done this all while the database has been running inside the cloud provider, which is pretty darn cool if you ask me. There you have it, EMC ScaleIO, software-defined storage that's high-performant and transactional block storage.